Okay, so our 8.3 practice, this, we got our last lesson coming today. Oh great, there's hair in my pencils. That's because they were all stuck in my hair last week. I think I picked 3 pencils out of my hair last Friday afternoon. Today's the 26th, but we started this on the 28th. Does anybody need a copy of this? If so, come up and grab one from me. If anybody needs a copy of this 8.3, doesn't have one, you need to get one from me. Oh, I have them right here. Now, first of all, in number 1, there's a couple things that we have to do. We have to determine whether ABC is similar to XYZ. So, first thing is, and I'm interested in you guys telling me what these fractions are equal. This shouldn't take me too long. So this is going to be me checking 25 over 2 compared to 15. Is that equal to the 18 over 12, which I know that's equal to this 18 over 12. Those two are. What about the 25.2 divided by 15 and the 1812? So are they congruent or no? No. All right. So ABC is triangle ABC not similar. Make sure you have a statement to triangle XYZ. Now we got to go and do second set is to double check this one. So 25 over 2, my numerators are all the same as they were in the other, except now this is over 14 and these are over 10. Are those all congruent to each other? Are those all 1.8? I know these guys are 1.8, yes or no? 25.2 over 14. So then we can say then that triangle ABC is similar. Nope, I'm lying. We just used ABC. This is DEF is similar to XYZ, and I'm even going to go so far as to say the K is equal to 1.8. Put that scale factor in there. If they're similar, you've come up with a scale factor. Now for number 2, I already had some math going on here on my page. I was showing this set up to another class on Friday. X plus 1. You can solve this a couple different ways. I set it up as this image, x plus 1 over 10, and then 4 over the 8. I'm going to get 10 times 4 is 40. And then this 8 times the quantity x plus 1. I think a couple people had come to me and said something about how I know the scale factor is 2, so do I have to solve all that? You definitely need to be able to go through the process. I think x winds up being 4. The scale factor is, maybe not. X equals 4, so this is 32 equals 8x, divide by 8. X is 4, this side length is 5, this side length is 6. Yeah, the scale factor of this is 2, but the missing X value is 4. Now, you can set up number 3 a couple different ways too, but I think I just like to do it simple as possible. 3x over 18, the ones I highlighted, this over the one I matched up in orange, equals 13.5 over 9. And when I cross multiply in here, I get 27x. 3x times 9 is 27. And again, you could solve this different ways and you'd get the same thing. I got 13.5 times 18 is 243. And then when I divide 243 by 27, I get 9. And again, had you set it up in a different way, you should still get 9. Regardless how you set that problem up, you should still get 9. Now, 4. I'm going to assume that find the scale factor of TUV to XYZ, that XYZ is going to be my image. So it's like what we did in our notes packet where we have, they're triangles. So I'm setting up 3 fractions, XY to TU, 35 to 15, 49 to 21, and 42 to 18. Now I just want to look and see, smallest, largest, yep, in the middle. Just wanted to make sure I had matched everything up correctly. And then when you divide these all out, they all work out to be 2.3 repeating. I do think, I'm checking them all right now. Yeah, or they reduce to, if you put them in as math frac to see what their reduced fraction was, these are all 7/3. K is 7/3. If you want to put that as a decimal, it's 2.3 repeating. 7/3 was a scale factor for all of them. Done some color coding down here on numbers 5 and 6. My image length is, where am I at here? So pre is going to be the smaller one. So my image lengths are 15 and 12, and corresponding with that is 10 and 15 and 12, 10 and 8. Now, do these reduce to 2/3? No. 3/2. Both of these reduced to 3/2. So that's my scale factor. And then my similarity statement has got to look like, what do I got here? Let me start with pre-image. CD is similar to, now I started ordering this way, BCD, so I'm going to go ACE. Had you written those in a little bit different order, that's fine, but the letters should be sitting in the same place. Like if your C's in the middle in one, your C should be in the middle in the other. If your C's out front in the first one, your C should be out front in the second one. But make sure you have that similarity statement there. We know they're similar because their scale factor is both K, or is both 3/2, and then our similarity statement. Now coming over here for number 6, I've got all my color coding done, my image length. Let me do this. Image, orange 21, peach 15, blue 27, and then corresponding underneath here, orange goes with the 14, the peach was the 10, and then the 27 goes with the 18. And are these all 3/2 as well? Yeah, every one of these reduces to 3/2. Your focus should not be on your phone right now, and if it is, that's a problem for both you and me. Put that up. Similarity statements then. I'm going to start in this corner between my peach and blue name. Triangle E, I'm going to go this way. GF is similar to triangle. So I went EGF, MLN. MLN. Our similarity statement on top of our scale factor showing they're the same. If there's not a pencil in your hand and you're not doing something, I guess I'm wondering why. Yeah. So I put the names in order, like, check it out. When I named this one, I went, this is going to sound funny, but I went peach, orange, blue when I named it. Peach, orange, blue on my colors. So then I had to start in the same place. Peach, orange, blue. Does that make sense? I started between blue and peach, and I went around this way. Peach, orange, blue. So then on this one, I had to go same peach, orange, blue. Name them in the correct order. Backside, couple things. First of all, the idea that that angle was missing there. It's 55.5 degrees. And then that side length was 11. Now, the first question is, triangle VWX is similar to what? Now, this one, triangle VWZ, and I've got it in yellow right here. It's similar to which other triangle? Well, at first I'm like, you know, how am I supposed to tell this? And then I realized that I had some stuff going on here. Do you guys notice that there is, this side length is 22, and this side length over here is half of it? It's 11. On this yellow triangle as well, this side length is 16. And on this one, there's half of it, 8. And that's what made me go, okay, to get from this triangle over to this one, it's divide those lengths by 2. And so if they've written this, and here we are again naming, they've written this as VWZ. So they went V, the hypotenuse of this, and then the short side. V hypotenuse, WZ is the short side. So I've got to look over here and be like, well, what is that one? Let's see. If I want to go hypotenuse, yeah, hypotenuse, X to Y, then short side would take me to Z. So I'd name that one, let's see, we were VWZ, we're going to be XYZ. XYZ, and that's a scale factor of 2. I'm just going to throw that in there because, oh, my bad, it's going to be a half because I'm going from the bigger one to the smaller one. Scale factor is not 2, it's going to be a half. X, Y, and Z. Now what's helpful about that is that now I've got, I know these are similar by what I've looked at here. I know that angle right there is going to be 36 degrees because in triangles that are similar, their angles are the same. Measure of VZY, measure of VZY. That's sitting at the intersection here. One of them is already marked 90 degrees, so that's going to be 90 degrees. The measure of, where are we at? VWY, V to W to Y. In this one right here, you've got one angle at 90 degrees, one angle at 36. 180 minus 90 minus 36 is going to leave us with 54 degrees up here. And then where are we at? Measure of WXY, WXY, WXY. I've got two measures in there right now. WXY is going to be 55.5 plus WXY plus the 36 degrees that's in there. It's going to be 91.5 degrees. That was probably the trickiest one. You had to get that 36 up in there. And then I added those two together. And then last but not least, this XY side that's right here. I'm going to bring this triangle, this XY side. There's Z, that's 8. This is Y. This guy was 11. There's X. I'm bringing this off the figure. It's this side length right here we have to find. It's that here. I brought it off the figure just to show that this is a leg missing hypotenuse. 11 squared plus 8 squared equals the hypotenuse length squared, that XY. It's going to be 121 plus 64 is C squared. That's 185 is C squared. How long is XY? It's going to be the square root of 185. When I go do that, second square root, I get about 13.6. So that's all of your missing lengths on that one.